In today's lesson, we're going to learn about some different ways that we can write numbers. Uh, you're familiar with the standard number writing system that we use today, just with using the digits between 0 and 9 and organizing them in a way to represent a lot of different numbers. Uh, this works better than some other writing systems that are out there. You may have heard of like the Roman numeral system or a few others like that that have largely disappeared from most use. But the reason why our number system, why we use it, is because it works very well for most things that we use. Um, However, when you start getting into quite a bit larger numbers or even quite a bit smaller numbers than we're used to, then that number system doesn't work quite as well as it could. So, as you can imagine, by the title here, scientific notation, um, in a lot of scientific fields, they need to use very big and or sometimes very small numbers to represent uh, various different types of information. So I'll show you really quickly how it works. It starts by using a decimal. So any decimal number between 1 and or between 1 and 10, or 1 to 9 really is usually where it's used. And from there, so using that decimal from 1 to 9, you simply multiply it by some factor of 10. And as we've learned, I'll just put a question mark up there to represent it. As we've learned, there can be all sorts of different factors of tens, but 10's a nice, easy number because it always just goes up by an extra 0 each time. So that's why they've chosen to use 10. So I'll just put this in brackets so that we know that it's some decimal number between 1 and 9 for the most part. So how does that look like in reality? So let's take a number. I'll use the population of Muskoka. So right now, the population of Muskoka, or at least in our most recent estimate, is at 58,047. So if we were to change that into a scientific notation, usually they keep the first couple of important digits and they don't worry about the digits that are down near the bottom, because they don't get, especially as the numbers get much bigger, the numbers at the bottom are less and less important. But we can easily change that by making it a decimal number between 1 and 9. So the number 5 here is a decimal number between 1 and 9. And we can keep the 0.8 if we want, or the 0.80. Probably don't want to go too much further than that, but we can definitely keep some of that information. So if we wrote 5.8 times 10, and then you have to count back how far you want to move the decimal. So we're moving it 1 space, 2 space, 3 spaces, 4 spaces to get to the number that we have here. So we simply write 5.8 times 10 to the 4. As I said earlier, we do sort of lose that 47 there, but generally when you're talking about populations, we're going to estimate that we're at around 58,000. The 47 people aren't usually considered as important. And when I look at it right now, for this size of population, it doesn't really have any real benefits to writing it in this way. But as the numbers get larger, so for example, the population of Canada in the latest census numbers has it at 35,151,728. So that's a bit of a bigger number. And if we change that into scientific notation, then we keep the first digit, so which is between 1 and 9. So the number 3 is between 1 and 9. And then we'll keep a couple numbers after that. I mean, you can sort of play with it as you will, but let's say we keep 5, 1, 5, and then times 10. And again, we got to see how much we're going to move that decimal. So from here, we're moving it 1, 2, 3, 4, 5, 6, 7 places. So 10 to the 7. So again, you see that that's becoming a little bit easier to see than this, but more or less the same sort of thing. How about if we go bigger again? So say the estimated population of Earth right now is estimated to be at about 7.5 billion people. So if we change that into a scientific notation, then we'd have something that would look like 7.5, because I have my decimal number between 1 and 9, which is the number 7, and I put 0.5. And we're going to move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So times 10 to the 9. So now we've got this nice little number that's representing this quite large number here. This gets to be even more obvious when you talk about really, really large numbers. So for example, if I was to do the weight of the Earth, and I looked that up earlier, and that number is approximately 5.9722 times 10 to the 24th power in kilograms. So if I were to write that out in our traditional notation, that would be basically another 23, 22, 21, 20. So another 20 zeros behind those digits if we took out the decimal. So the number would go over to here. It would be really a cumbersome number to deal with, especially if you were trying to, say, measure the weight of the sun or other things like that. Then it would even get much more ridiculous. So that's scientific notation. So it's very easy to transfer back and forth between the two, as you notice how I've done it. All you have to do is really count the number of decimal places that you're shifting and put 10 to the to whatever power that is. So hopefully you can get a chance with that. Now another type or another way to write numbers is using expanded form. And this is used in some mathematical techniques and especially in algebra. It's not used very often in your day-to-day life, or really almost never in your day-to-day life. At least with scientific notation, you do see it when you see things like the mass of the Earth. But it's basically taking each single digit in a number. So if we were to again use the population of Muskoka, we have 58,047. So expanded form takes every single digit into account, so that's important. But what it does is it looks at each digit and then moves the decimal according to that specific digit. So for example, the 50,000 in our 58,000 turns into 5 times 10 to the, and then again you start with your decimal at the end of the number as it would be here, and you move it 1, 2, 3, 4 places up. So 10 to the 4. And then you're going to add that to our 8,000, so 8 is the whole number, times 10 to the 1, 2, 3. And we'll add that to, we don't need to bother with the 0 because 0 times 10 to the 2 is still 0, so we just ignore that number. The next number we have is the 40. So that would be 4 times 10 to the 1, which is basically 10. And then finally plus 7. And we don't need to bother putting 10 to the anything because it's not a multiple of 10. It's still in the ones column. Another way to think about this is if you remember using the different columns. So, for example, we would have our, starting at the decimal, we would have our, that would be called our ones column. And this would be called our tens column. This would be called our hundreds column. And so on and so forth as you get to thousands and 10,000s and 100,000s and millions and tens of millions and so on and so forth. So this is really just the same idea of splitting it into columns of the ones, the tens, we skip the hundreds because there is no hundreds, the thousands, and then the 10,000s. And so that's all that represents. So for the assignment today, you're going to be transferring numbers between the traditional form that we've always used and into scientific notation, as well as expanded form. I hope this has been useful.